All right, in 6.2, or integration by substitution, I learned it as integration using use substitution because we will use. Okay, so like before when we first got started with 6.1, I showed you some functions, some derivatives, and we were like, what function? Well, still, we're finding antiderivatives, but we're undoing the chain rule now, okay? So I think what would be helpful is that if I showed you the chain rule, and so you can remember the chain rule, so we can show you how to undo the chain rule. Chain rule always involves a quantity to a power. Okay, let's just look. Let me write down what I'm talking about here. Okay, so and substitution. So let's just say from 267, we had y is equal to 5 times x squared plus 1 to the 4th power. And if we wanted to find the derivative, we would have used the chain rule. Okay, so what that told us to do is just like the simple power rule. You multiply down times the inside. The inside never changes, and we subtract an exponent, but we multiplied it by the derivative of the inside. Okay? All right, and that was really important because let's look and see what we did. We took this quantity, and to take the derivative, we multiplied down and subtract an exponent. Same as before, but we multiplied it by the derivative of the inside. So how do you think we're going to undo that? Well, the inside won't ever change. We'll add 1 and divide, but instead of multiplying by the derivative of the inside, we're really going to be dividing by the derivative of the inside. But it's called substitution. So I'm going to show you, if I take this problem, I can multiply the outside, 40x times x squared plus 1 cubed. Okay, so if we integrate this, we're going to use the method, and it'll always say use substitution. So we're going to take this complicated problem and rewrite it in terms of u, and then integrate it like we've used in our 6.1 rules and our rules from just basic integration. Okay, so and I have the steps all written down for you, so I'll put those up in just a second. But I always let u be the inside. Okay, so if I let u be the inside, it's x squared plus 1. Okay, and it's important that I find the derivative of the inside, because to do the chain rule, I had to multiply by the derivative of the inside. So we've got to have the derivative. So u and du, and the derivative is 2x, and I'm going to put dx, okay, because it is the derivative with respect to x. Since we have 2 variables, I have to write that. You don't so much have to write that, so don't worry about it. So what I'm going to do is I'm going to rewrite this complicated function in terms of u. Okay, so this will be the x part, and this will be the u part. So you can't mix up your u's and your x's. Okay, so it's just like you don't want to bring your x's into the future and mix them up with the new u's. Got it? So what I'm going to do is I'm going to rewrite all of this in terms of u. So look, I already know that this right here is u, right? So I can bring this over here as u cubed. Okay, and I've done that. I've written it. I'm going to bring my constant over like I always do. Okay, I just bring that number over just like I did before. Okay, and so what's left over now? X times dx. All right, do you see that? I've taken my 40 over. I have taken my u cubed over, and so I have x dx in my original problem, and I need to put those in terms of u. So what I'm going to do is look at my derivative, and I have what? 2x dx. I just need x dx. So what do? We divide by 2. So I have x dx is equal to 1/2 du, or du over 2. I like to write it as 1/2 du. Okay, so now x dx is just 1/2 du, and I've done it. I've rewritten this integral in terms of u. So this was u cubed, brought it over, brought my 40 over, And so I had x and dx left over in terms of x. So that's where I look at my derivative, and I had 2x dx. So I divided both sides by 2, and you could have just put in, I don't think that's a word. X dx is just du over 2 or 1/2 du. So maybe it'd be easier just to put du over 2. So x dx, I put the du there and I put it over 2. And so now I have this integral 40 over 2, which is what? 20u cubed du. And so I'm just using rule 2 from before. I'm going to add 1 to my exponent, bring over the 20, add 1 to my exponent, and make it u to the 4th divided by 4 plus c. And so that is what? 5u to the 4th plus c. But how do I get it back in terms of x, back in terms of my original function? Then what is u? It's 5 times u, which I, up here, x squared plus 1 to the 4th power plus c. And you can see that's where I started off. I took that at the beginning and found the derivative, and then I took the derivative, and using substitution, I got my function back. And so that's where, you know, it gets a little complicated, maybe sometimes rewriting it, but then we're just going to use our same old integration rules that we already have in order to do this. Okay, so I'm gonna put the steps up. I've already written them out, and so I'll post these on Blackboard too. So if you just want to. Okay, so whenever I do integration by substitution, if I have a denominator, I would move my denominator up that says if applicable. And then I pick u, just like I did before. So I always let u be the inside quantity. Sorry, my phone's going off. My dog's been barking. U be the inside. Or if there's no inside, we'll let u be the exponent on e, but we'll talk about that in a minute. And then find the derivative of u. Okay, so that's what I did here. I had this problem. You can't really see it. I let u be the inside, and then I found the derivative of u, which was 2x, right? Okay. And then I said move any outside constant terms over. So I moved that 40 over. Okay, so I have 40u cubed, and I said, well, I have x dx. So I rewrite the original integral problem in terms of u, and I should put using du and du. Okay, sorry about this. All right, so what you're going to have here is, let me see if I can do that. Once you rewrite it, okay, you're either going to have what I have, 40u cubed, right? 20u cubed, I just add 1 and divide it. You're going to have u to a constant times u to the power, add 1 and divide, or u to the -1, which is the ln of u, or you're going to have e to the u. So, and once we integrate, then you just substitute it back in for u. So those are my steps, and those are the only steps I'm going to use for 6.2, or integration by substitution. So let me work an example. I'll post these just along on Blackboard, so you'll have the steps, okay? And it always tells you to use substitution. So I'll tell you what I'm going to do. No, I won't do that. All right, so let's do a couple of examples. Let's see the integral of 7x squared times x cubed plus 3 squared dx. Okay, and it says use substitution. And whenever, to me, it says use substitution, that means I'm going to need u, and I got to find du. Okay, that's just substitution. That's what that means to me. Okay, all right. So I know I have to rewrite. Let me write it like this. like to go across. I'm going to rewrite this in terms of u. So there's no, my first term said move any denominators up. There was no, if applicable, there was none. So I pick u. So u is always going to be the inside of the quantity. Do I have an inside? Yes. So my u is x cubed plus 3. And I always find the derivative of u, which is 3x squared dx. Okay, that's important because you're going to have to use it for your substitution. Okay, all right, so let's see if my steps make any sense. Okay, find the derivative. Move any outside constant terms over. So I've got this 7. I'm going to go ahead and move that over, and I already have u squared. So I move my 7 over, and I have this quantity squared. So this I have used, I've rewritten in terms of u. What's left over? X squared dx. So I'm going to use the derivative to solve for x squared dx. And how do I do that? I just divide by 3. So du over 3 is x squared dx. So I make my final substitution. X squared dx is du over 3. And now my integral in terms of x is now an integral in terms of u. And so I'm going to, this is just going to be rule 2. So I'm going to add 1. I bring my constant term over, right, 7/3. Add 1 to my exponent, 3 divided by 3 plus c. So that's going to give me 7u cubed over 9 plus c. But remember, we have to put it back in terms of my original function. So that's 7 times x cubed plus 3 cubed over 9 plus c. Okay. All right, so let me do one of each kind. One with the ln and one with an e, and then we'll go look at the practice problems. And these are the steps. Okay. So let's do this. We'll do a couple more, and then I'll do the e one. Let's do the integral of 3x to the 4th over 7x to the 5th minus 4 dx. Okay. All right, and it says use substitution. So whenever it says use substitution, I know that I'm going to have a u and I got to find my du. Okay, that means I'm rewriting everything in terms of u and du. All right, but I'm going to take this integral, and it said my first step is always, we haven't had to use this first step before, move any denominator up. Okay, so I'm going to move this denominator up. So 3x to the 4th times 7x to the 5th minus 4. And I'm going to move the whole thing up. Okay, so it's understood to be to the first power. So when I move it up, it's going to be to the negative first power. Okay, all right. So now I have my integral with x's, and I'm going to turn it into an integral in terms of u. Okay, pick u. Is there an inside? Yes, as long as there's an inside to a power, a quantity to a power, u is always the inside. Okay, and then I find the derivative of u. It's 35x to the 4th dx. All right, so these are the two things I'm going to use to rewrite my integral in terms of u. I usually just go ahead and move the u over. Okay, so that's gone. Move that over. And I'm going to bring my 3 over. Let's just bring my 3 over. And what's left over? X to the 4th dx. So that's where I use my derivative. X to the 4th dx is right there. I just have to divide both sides by 35. And then du over 35 is x to the 4th dx. So I put x to the 4th dx as, oops, yes, x to the fourth dx is du, goes on the end, and I stick it over 35. Okay, so now I have my integral in terms of u. So again, I'm going to bring my 3 over 35 over my constant term. And what happens when I add 1 to the exponent? I get 0 divided by 0. So I can't use my rule 2. I have to use what? My rule 3. Okay, because that's going to be what? The ln of the absolute value of u plus c. So that's my answer. But I have to turn it back in terms of the original variable. And it doesn't matter if you write 3 ln all over 35 or put the 3 over 35 in front, as long as you know when you use the practice problems, if it takes it for the practice problems, it's going to take it for, you know, the quiz problems and everything else. So let's put it back in terms of the original variable, and then we'll look at an E problem. So that's 3 times the ln of the absolute value of u, 7x to the 5th minus 4, plus c, all over 35, or you could do it as 3 over 35. It does not matter. All right, so that's an ln problem. Okay, let's look at an example of a problem with E in it. Okay. All right, so let's just do the thing about e's, right? We already know from our basic rules. Rule 4, and we'll use this a ton throughout the semester, from the previous section, it was the integral of a constant times e, well, we called it c, a constant times e to the kx dx was the constant times e to the kx divided by k. Okay, so the key here is that we can use that whenever the exponent on E is 5x or 2x or 3x, but when the exponents become x squared or x cubed or x to the 4th, we can't use the 6.1 rule on that anymore, okay? And so whenever I can, that's C, constant times E. So an example, just real quick, of that would have been like 10 e to the 2x dx. Well, I can use 10 e to the 2x divided by 2 plus c, and I can leave it like that or call it 5 e to the 2x plus c. So if I can use that rule, boy, I use that rule, okay? And the only way you can is if the exponent on e is linear, meaning x is to the first power. But now when I get in a situation, it tells me to use substitution. So and when it does that, you know you're going to have a u and a du, right? But let's look at this problem. This is the integral of 7x e to the negative x squared plus 1 dx. Okay. So right away I see that my exponent on e is not 5x or 3x or 2x. It's to the x squared. So look, let's look at our rules again. I like steps, okay? So it says move any denominators up, and you can't move any denominators up because there aren't any. And you pick u. So u is always the inside of the quantity, but now there's no inside. So now we let u be the exponent on e, okay? All right, and so that's when we get down to here. When we integrate, we're going to be integrating some constant times e to the u, which is just some constant times e to the u plus c. All right, so instead of u to a power, we're going to have e to the u. So let's look at my steps. Don't forget my steps. So u is the exponent on e, and the derivative of u is negative 2x dx. Okay, all right, so I am, what does it tell me to do? Move any outside constant terms over. So I'm going to rewrite this with the 7 there, right? Instead of u to a power, this is going to be e to the u, okay? All right, so now I have 7e to the u. What's left over here? X dx. So I'm going to divide by negative 2, and x dx is du over negative 2. So x times dx is du over -2. Okay, so how do I integrate -7/2 e to the u? When you have a constant times e to the u, it's just a constant times e to the u, you're really dividing by 1, okay? So the antiderivative is 7e to the u over -2 plus c, but I have to put it back in terms of x, okay? So that's 7e to the negative x squared plus 1 over -2 plus c. And that's my answer. And so that's every kind of substitution problem that you'll have. So in my next video, I'll work all the practice problems, and you can watch those or not, just whatever works for you. But I'll have them all worked out, so you'll have examples of them. And so that is, let me see what I'm doing here. That is all the information that's on test 1. I mean, boom. So you got to practice, practice, practice. And math is not a spectator sport. You do have to practice these, but these aren't really bad hard. And I know that you can do it. So I'm going to end this. I'm going to go video myself, working the practice problems. If you want to watch that, that's fine. And so, but no, there's a lot of stuff you want to keep up and do your homework, because there's a quiz due on quiz 1 is 6162. There's a practice test for bonus. I mean, you don't have to work the practice test. It's not worth a lot. You don't have a lot of time to do the quiz, the practice test, and everything. So, just, you got to do the quiz for credit, got to do the homework for credit. And at that point, you're probably ready for the test. If you want to work the practice test, you can. But anyway, you'll ask me questions, and yeah, ask me questions if you need to. Okay, all right, see you soon.